Alright, problem 173 says use the definition of a derivative to write an expression representing each of the derivatives. So part A, we have to find f prime of x where f of x equals 1 over 2x plus 1. So first we start by writing down f of x and the definition of a limit. So f of x plus h minus f of x all over h. Then we do that again and plug in x plus h into our original f of x equation, so it becomes 1 over 2x plus h plus 1 minus 1 over 2x plus 1 all over h. So this is the initial expression that we have to find. Now we just have to solve for the derivative. So we start by simplifying this equation, so it becomes 2x plus 1 minus 2 of x plus h plus 1 over h times 2x plus h plus 1 times 2x plus 1. Expand that out, so it becomes the limit of, as h approaches 0, of 2 times x plus 1 minus 2x plus h plus 1, and then h times 2x plus h plus 1 times 2x plus 1, which equals the limit. So the x plus h's both cancel out, and it becomes 2h times h times 2x plus h plus 1 times 2x plus 1. And these two h's cancel out. It becomes the limit of, as h approaches 0, of negative 2 times, or over 2 times x plus h plus 1 times 2x plus 1. Then we have to plug in 0 to solve for the limit. So it's negative 2 over 2x plus 0 plus 1 times 2x plus 1, which equals negative 2 times 2x plus 1 times 2x plus 1, which we can combine into getting our ultimate answer of negative 2 over 2x plus 1 squared. Second part of this problem, you need to find h prime of x, where h of x equals x minus 2 to the negative 2. So again, start with the initial, where the definition of a derivative where the limit is h approaches 0. So f of x plus h minus f of x over h. And you plug in x plus h into the initial equation, so it becomes x plus h minus 2 to the negative 2 minus x minus 2 to the negative 2 all over h. And then we multiply it so that the exponents become positive. So then it becomes the limit as h approaches 0 of negative x plus h minus 2 squared plus x minus 2 squared over h times x plus h minus 2 squared times x minus 2 squared, which expanded out is the limit as h approaches 0 of x squared minus 4x plus 4 minus x squared plus 2xh minus 4x minus 4h plus h squared plus 4 all over h times x plus h minus 2 squared times x minus 2 squared. And then combine like terms, cancel things out, so it becomes negative 2x plus 4h minus h squared times, or over h times x plus h minus 2 squared times x minus 2 squared equals the limit of, as h approaches 0, of h times 2x plus 4 minus h times h times x plus h minus 2 squared times x minus 2 squared. So we factored out the h from over here so that these two h's cancel out. So it becomes even further simplified to negative 2x plus 4 minus h over x plus h minus 2 squared times x minus 2 squared. Then we solve for the limit where we plug in 0 for h, so it becomes negative 2x plus 4 minus 0 all over x plus 0 minus 2 squared times x minus 2 squared, which equals negative 2 times x minus 2 over x minus 2 to the fourth. This cancels out with this, so then it becomes negative 2 over x minus 2 to the third. The final problem for number 173, so you have to solve for g prime of 4, where g of x equals x. So to the expression g prime of 4, the original definition of a derivative is g of x plus h minus g of x all over h. Plug in 4, ignore that. So the expression for g prime of 4 is is the square root of 4 plus h minus root 4 all over h. But then to solve for the derivative, you have to find the limit as h approaches 0 of 4 plus h minus 4, which is that, and then all over h times square root of 4 plus h plus 2. So in order to get this, you needed to multiply the numerator and the denominator by the top expression to get rid of the square roots. So you get that, and then you go down to the limit as h approaches 0. It's simplified to 1 over the square root of 4 plus h plus 2, which equals to 1 over 2 plus 2, which equals to 1 over 4.